Okay, in this video we're going to talk about multiplying and dividing rational expressions. Now, really quick, talking about the difference between an expression and an equation. An expression simply does not have equal signs, okay? So if we ask you to simplify an expression, you don't have to find the value of x. Soon we are going to solve for x, but not right now. Right now we're just simplifying the expression, so we're not solving, we're not figuring out what x equals. Okay, so the way we are going to simplify rational expressions is we're going to need to factor the numerator and the denominator. So if you're still having trouble with factoring, we really need you to ask us for additional help and extra practice because you need to know how to factor in order to do these sections, okay? So a quick review on factoring here. Looking just at the numerator, okay, we're asking what two numbers multiply to give you a negative 3x squared and also add up to give you the middle term of negative 2x. Okay, and hopefully you're thinking that's negative 3x and positive 1x, negative 3x, positive 1x. So those are actually, because a equals 1 in this case, we can take the shortcut and say that my factors are x minus 3, x plus 1. Then I'm going to do the same thing with my denominator, looking at my denominator here. What two numbers multiply to a times c, so that would be 6x squared, but also add up to my middle term of negative 5x. Okay, so in this case, I'm going to do negative 3x, negative 2x, negative 3x, negative 2x. Okay, so make sure that it satisfies both the multiplication and the addition. So in this case, my my factors are x minus 3 and then x minus 2. Okay, so what's going to happen is when we have a common numerator and denominator, it's going to cancel out. And now this simplifies to just x plus 1 in the numerator, x minus 2 in the denominator. So this would be my simplified rational expression. Okay. Now we can also simplify other things such as exponential expressions. So in this case, for 8x to the 10th power divided by 4x to the 2nd power, I'm going to look at my numbers first and just focus on my numbers. What is 8 divided by 4? Okay, and in this case, it would be 2. And then thinking about how to simplify exponents, when you're dividing exponents, you end up subtracting. So I'm going to show this in a way that we're going to be factoring just so we can make that connection. But you could, if it involves exponents, you could go back to exponential properties. So if I wanted to factor the numerator to see if I can get it to have something in common with the denominator, let's say my goal here is to cancel them out, I would factor out the same amount, x squared and 4 possibly, if possible. So then when I factor it out, think about, okay, 4 times what would give me 8? And the answer there is 2. And then if I take out 2 x's out of the original 10, that means I have 8 left over. So I could also factor out and simplify it this way, because what will happen there is they'll cancel out. And then my simplified expression here would be 2x to the 8th. Okay, so two ways to do it. You can either do it using exponent properties, or you can factor it out to see if you can cancel something and go from there. So looking at the second one, if I'm trying to simplify it, I'm trying to cancel things out, I'm going to see if I can factor anything from the numerator first. So x squared and 7x both have an x in common. So I have x plus 7 here. And then I can rewrite x squared as x times x. Okay, when I do this, it's easier for me to see that these x's can cancel out. So then the way I can simplify this expression would be x plus 7 in the numerator and then just 1x in the denominator. And that would be my simplified fraction there. Okay, so as a general rule, we're going to simplify by factoring both the numerator and denominator, and then we're going to cancel out any common factors that we have. Okay, so let's jump right into the first example. So in my first example, I'm going to look at the numerator and factor it. Again, if you need extra help with this, let us know. But I'm just going to go right into it. This factors out to x minus 5, x plus 3. The denominator is a difference of squares, which we dealt with a lot last semester. And this is x plus 3, x minus 3. So you're always looking for those factors that are going to cancel out. I see that I have an x plus 3 in the denominator and an x plus 3 in the numerator. Therefore, they're going to cancel out, leaving my numerator just x minus 5 and x minus 3 at the bottom. Okay. So we're going to do that every single time. Factor the numerator, factor the denominator, see if anything cancels. Going to the second one again, ask yourself what two numbers multiply to negative 3x squared but add to a negative 2x. Okay, that comes out to be x minus 3, x plus 1 for my factors. And then do the same thing for the denominator. What two numbers multiply to a negative 6x squared? So remember, you always multiply a times c and add up to your middle term. In this case, that's a negative 1x. Okay, and when you do that, you get x minus 3, x plus 2. So again, looking for what the numerator and denominator have in common, that's what's going to cancel out, leaving x plus 1 in the numerator, x plus 2 in the denominator. And this is my simplified expression. Okay. All right, one more here just to practice simplifying, and then we're going to go into actually multiplying and dividing these expressions. So numerator again, what two numbers multiply to negative 24x squared and add up to that negative 11x? Okay, so hopefully for this one you're thinking x minus 3, x minus 8, because if I were to add negative 3 and negative 8, I would end up with a negative 11 there. But if I were to multiply negative 3 times negative 8, that's how I would get a positive 24 there. Same thing with the denominator, two numbers that multiply to negative 40, but somehow add up to a negative 3x. Okay, so I know I multiplied 40 by doing 8 and 5. One of them has to be negative. That's the bigger number, has to be negative, because their sum has to be a negative 3x. Okay, so same idea here. We're going to see what the numerator and denominator have in common. That's going to cancel out, leaving x minus 3 in the numerator and x plus 5 in the denominator. And that's how I simplify my expression. So now let's go into how to apply this into actually multiplying and dividing rational expressions. So in order to multiply rational expressions, we have to factor both the numerator and denominator. So just what we did. We're going to rewrite it as one fraction. So think about when you multiply fractions. Here's how you multiply. You multiply straight across. Something like 2/7 times 3/10. You would multiply the numerators together, 6, multiply the denominators together, you get 70, and that's your new fraction, okay? So that's why we're able to write it as one fraction, because we're technically multiplying the numerator factors together and the denominator factors together. And then once it's one big fraction, we're going to cancel any common factors out, just like we did previously, and simplify the expression, okay? So let's start off by factoring, again, both numerators, both denominators here. So this numerator, numbers that multiply to 12 but add up to 6, that's going to be x plus 6, x plus 2, okay? And then this numerator, again, I'm multiplying technically these two fractions. multiplies to 15 but adds up to 8. That's going to be x plus 3, x plus 5. The denominator, I'm going to factor that, so numbers that multiply to negative 15 but add up to a positive 2, that's x minus 3, x plus 5. And then second denominator here multiplies to 18 but adds up to a 9, that would be 3 and 6. Okay. So technically when we're multiplying these two together, I combine them to be one big fraction. Okay, so by one big fraction, here's what I mean. I can just extend this and say, okay, now they're one big fraction. You can rewrite it if that's easier for you, but that is not necessary, okay? So not necessary for you to do that. Now that we're looking at this as one big fraction, I'm going to look for things that are in common in both the numerator and denominator now that this is one entire thing. So here's x plus 6 and x plus 6. Okay, here is x plus 3 and x plus 3. Here's x plus 5 and x plus 5. Okay, so if all those things that they have in common end up canceling out, what is the only thing we have left over? We have an x plus 2 in the numerator and an x minus 3 in the denominator. And that would be my final answer, my simplified expression. Okay, so we are just adding a step to what we just did a little bit earlier. We are combining, multiplying two fractions together, and then seeing what cancels out once I do that. Going on to number 2, again, just take it one at a time. Not all of them are going to be trinomials. So like in this case, the only way I can factor out 4x minus 8 would be to take out a 4, and then I have x minus 2 in the numerator. Okay, then in the denominator for this one, again, numbers that multiply to negative 6 but add up to a negative 1, that would be x minus 3, x plus 2. Going on to the second one, this is a difference of squares. So this is actually x plus 3, x minus 3. And this one, again, it's a little bit different, so I might have to do an extra step. First, the only way to factor it would be to take out a common factor of x. That gives me a trinomial x squared plus x minus 6. Okay, so I have to further factor this part out. I'm going to rewrite it as the one fraction just so you guys can see what I mean, but you do not need to combine them into the one fraction here. My numerator is just all of the things at the top, right? So then this is 4x minus 2, x plus 3, x minus 3. This is the step that you can skip, just putting it all in one fraction. In the denominator, I have all of this. Make sure that you factor this a little bit further, though, into x plus 3, x minus 2. So then in the denominator, I have x minus 3, x plus 2, x plus 3, x minus 2. Okay, so again, go through and see what you guys have in common in the numerator and the denominator. So x minus 2, x minus 2, x plus 3, x plus 3, x minus 3, x minus 3. And then see what is the only thing you have left over in the numerator. That's a 4. The only thing you have left in the denominator is this x and this x plus 2. So we are going to leave it here. It's possible that if this was a multiple choice question, they went ahead and multiplied this back out, giving you x squared plus 2x. Okay, but either one of these would be fine. You don't need to distribute it, but know that either of those could be on a multiple choice. They wouldn't give you both, obviously. Okay, let's do this last one, last multiplication one before we go into division. So go ahead and pause the video now and try this one on your own, then come back and check your answer. Okay, the numerator here factors out. I'm going to take out x squared, that's what they have in common, leaving me with x squared minus 4 inside. This one is a difference of squares, so x squared minus 9 factors 2x plus 3x minus 3. Okay, this one over what numbers multiply to a 9 and x squared but add up to a negative 6x, and that is x minus 3, x minus 3. The denominator here is going to require a little bit more factoring out. So all of those terms have an x squared in common. When I take out the x squared, I'm left with x squared minus 4x plus 4, which means I have to further factor this part out. Okay, this part factors out to x minus 2, x minus 2. So just to make it all 1 here, I'm going to rewrite it all. The numerator, nothing changed. I still have x squared. Oh, just kidding. We have to further factor this one out. X squared minus 4 is a difference of squares, which factors out to x minus 2, x plus 2. And then on the right, we don't have anything that's changing. We still have x minus 3 and x minus 3. So it just got a little longer. In the denominator, these stay the same, x plus 3, x minus 3. We still have that x squared, but then we said that this factors out a little bit more, 2x minus 2, x minus 2. Okay, so let's see what cancels out here. We actually have an x squared in the numerator and the denominator, so that cancels. We have an x minus 2 and an x minus 2 here. We have an x minus 3 and an x minus 3 here. And that's about it as far as canceling numerator and denominator, okay? So we have x plus 2 and x minus 3 in the numerator, and x plus 3, x minus 2 in the denominator. Okay, so just be careful. It could be easy to assume that these are going to cancel, but remember, it's numerator and denominator, and they have to have the exact same sign and everything. All right, now we're going to move into dividing rational expressions. So we're going to follow the division rules for dividing. Some of you may have learned it at skip, flip, multiply. I learned it at keep, change, flip. So whatever, however you learn to multiply fractions or divide, sorry. So something like this, you would skip this one, so leave it alone. Flip this one, so make it 7/5. And then multiply straight across, giving you 14 over 15. So we're going to follow that same idea of dividing fractions for these rational expressions. We're going to factor both the numerator and denominator, rewrite as one fraction, cancel out any common factors, just like we've been doing, okay? So here we go with the first example. We're going to factor the numerator here. So I know I'm going to skip this one. It's going to just stay exactly the same. I'm going to go straight into factoring it. So x squared minus 2x plus 1 factors out to x minus 1, x minus 1. So that's this one right here. Then my denominator, x squared plus 6x plus 8, factors out to x plus 4, x plus 2. I know that this is going to turn into a multiplication problem. And then I'm going to have to flip this second fraction. Flipping means that this is going to become the new denominator, and this is going to become your new numerator. So my new numerator factors out to x plus 2, x plus 1. And my new denominator, difference of squares, is an x plus 1, x minus 1. Okay, so I'm going to go ahead and see what cancels out here. We have x minus 1, minus 1. Let's see, plus 2, plus 2, plus 1, plus 1. So the only thing left in my numerator is an x minus 1. And in my denominator, an x plus 4. And that is my answer. That's me simplifying it. So really the only thing that changes is adding that additional step at the beginning. Going on to example 2, same idea. I'm going to skip this one. I'm going to flip this one, meaning this is going to become my new denominator and this is going to become my new numerator. So starting with my top expression, I can Factor that as x squared minus 9. Now, if you notice right away that this is going to turn into a difference of squares, feel free to go back and say, well, I know that x squared minus 9 is going to factor 2x plus 3, x minus 3. So let's just fix that now, okay? You don't have to wait for another step to do that. That's x plus 3, x minus 3, and then continue with your factoring. So my denominator here, what multiplies to 24 and adds up to 11, I get x plus 3 and then plus 8. I know that this is going to change to a multiplication problem, and this is going to turn into my new numerator because I'm flipping the second fraction. So what multiplies to negative 8 and adds up to a positive 7, that's a positive 8 and a minus 1. And then the new denominator is this one. So what multiplies to 3 adds up to negative 4, a minus 3, and a minus 1. Going through and canceling things out, we have a plus 3 here, plus 3, minus 3, minus 3, plus 8, minus 1, minus 1. So the only thing that survived was the x in the numerator. So we leave it like that. Technically, it could be over 1, but we don't need to write that part. So just number 2 is just x. All right, going on to number 3. This one looks a little different, but it's still a division problem. So we are going to skip this one, meaning we're not going to do anything except factoring it. We're not going to flip it or anything. So when I factor the numerator, I can take out a 2, leaving me with x minus 3 in the numerator. And then the denominator, this right here, what multiplies to 20 but adds up to 9. That's positive 4 and positive 5. Okay, then I know this is going to change into a multiplication problem, and then I'm going to be flipping the second fraction here. So this is going to become your new denominator, and this is going to become your new numerator. The denominator, it's a difference of squares, meaning it factors to x minus 3, x plus 3. The new numerator, because we're flipping it, factors out to x plus 4 and x plus 1. So now that I went ahead and factored everything out, I can see what cancels. So we have an x minus 3, x plus 4, and it looks like that's it on this one. So in the numerator, we just have 2, x plus 1. And in the denominator, we have x plus 5 and x plus 3. Going on to number 4. So number 4, same idea. We're going to go ahead and skip the first set of fractions. Now for this one, we're going to factor the numerator. The numerator here is a difference of squares, but difference of squares with a x squared term. So it would be x squared plus 9 and x squared minus 9. Okay, the denominator in this case, we can start by taking out a 3, leaving me with x squared plus 9 in the inside. I know this is going to change to multiplication, and then this is going to flip. Therefore, this is my new numerator, and this is my new denominator. So the denominator factors out to x plus 4, x minus 3. And then the numerator factors to x plus 4, x plus 1. Now, looking at the numerator and denominator, I can see that these match. So I could further factor it, or I can stop there because I know it's going to match and cancel out. So I'm actually going to stop there. But this one, the x squared minus 9, is going to factor out further to x plus 3x minus 3. So I'm going to rewrite this as one entire big fraction, just so you can see. Again, I'm not doing anything to the x squared plus 9 because I can already see a common factor in the denominator that it's going to cancel out with. But I am going to further factor x squared minus 9, which is right here, x plus 3x minus 3. Bringing the x plus 4, x plus 1 over from the other numerator, and then continuing to write down the other terms. So now that it's all one big fraction, I can see what cancels. So again, we talked about x squared plus 9, x squared plus 9. We have an x minus 3, x minus 3, x plus 4, x plus 4, which leaves me with, in the numerator, an x plus 3 and an x plus 1. And in the denominator, just the 3. So this would be my answer. All right, going on to number 5. So number 5 combines several steps here. It's asking us to multiply, but then it also has a division. So I'm going to focus with the division first. Okay, you're going to follow the same process. You're going to skip this part. You're going to flip this one, factor it out, see what cancels out. Okay, so when I focus on just the numerator, this is a difference of squares. So this is going to factor out to x plus 7, x minus 7. Looking at the denominator, I can factor out a 3, leaving me with x minus 4 here. I know that this is going to turn into a multiplication problem. And so then this becomes my new numerator. So x plus 5 here. And then this becomes my new denominator. So that factors to x plus 7, x plus 7. So what I'm going to do now is, now that I have all multiplications, I'm just going to bring them all down. So I'm going to bring this down, this down, and this down. So turning it into one big problem, x minus 4, x minus 7, plus 7, minus 7, the 3x minus 4, x plus 5, and then x plus 7, x plus 7. And same process, I'm going to see what factors out or cancels out. So cancel, cancel, this cancels, and then the x plus 7 cancels with one of them, meaning that I have x plus 5 in the numerator and a 3, x plus 7 in the denominator. So sometimes we'll give you multiple things going on, so just work your way from maybe the more complicated, simplify it a little bit. And all right, for number 6, here is what we are going to do. We're going to factor, you can take care of this first, or just do it all at once. We know we're going to keep this the same because we're just multiplying, and then we're going to skip, flip, and multiply these. So when I factor the numerator here, I get the following, the denominator. Then again, I'm going to skip the first one, so the x minus 5 and the x minus 2 stay the same. Then I'm going to flip it. So this is my numerator, this is my denominator. The numerator is going to factor out 2x, x plus 3. The denominator, 2x plus 3x minus 3. And then go on and cancel things out. Minus 2, minus 2, minus 3, minus 3, minus 5, plus 3, leaving with x on top and x minus 3 in the